Yeah, my name is Chris Rogers, and I'm going to talk a bit about the history of the Web Audio API, how it came about, and some of the design decisions that went into making it. So, first of all, I have to click on the, okay. So, who am I? Well, I was the first Web Audio API specification editor from 2010 to 2013. I was also the implementer in WebKit for the Web Audio API. And also, I was working at Google as audio backend engineer for Google Chrome. So, all of the kind of nitty-gritty details, the low-level platform-specific code, and all of the inter-process security stuff to shuttle audio back and forth. I worked with a team of engineers there to help make sure that the system could be as low latency and performant as possible for all the platforms. So what am I doing now? Well, I retired from Google in 2013, and I'm still working as an audio developer, but just working on my own personal project, just kind of messing around with my own software. I've been working on my own digital audio workstation software for a long time, so I wanted to get back to doing that and making music. So I'm just producing music at home, composing, and I'm kind of messing around with the piano, practicing every morning. So here's the overview of what I'm going to talk about. So I'm going to touch briefly on some technological trends in audio processing that kind of led up to our ability to even have something like the Web Audio API. I'll talk about some of the early technology on the web for audio and the very early days in the birth of the Web Audio API, and then how that developed over time. And towards the end, I'll talk a little bit about the Web MIDI API, and then some latest developments in Web Audio, the audio worklet, which I had nothing to do with, but I think it's a very important and interesting new development. So, yeah, it's kind of interesting to think about all of the technology that had to exist to be pre-existing before we could have something like the Web Audio API or even have laptop computers that can run web browsers. You know, we had to learn how to harness electricity, and the transistor had to be invented, and integrated circuits had to be invented, and many more things before we could have laptop computers, desktop computers, and web browsers, and all this kind of stuff. So, back in the early days for audio, people were using old analog gear and doing magnetic tape editing, musique concrète, and playing around with early digital computers where you might use an early music programming language like Music 5 or even later C Sound, where you would write basically a script using the music language and run it on the computer. It would run for overnight or several hours at least, and then you'd get maybe just a couple minutes of music. So it was non-real time. And then gradually the digital technology with integrated circuits and so on, it became developed enough where hardware synthesizers started coming on the market, which were digital, like this Yamaha DX7. And then, around that time, there were early home computers, but the CPUs were simply not fast enough to really run native audio code. It was all just dedicated hardware. But, later on, the trend went, as the machines got faster, laptops and desktops got faster to run native audio applications. So before that happened, though, all of the audio code had to run on custom DSP chips, which are really hard to program. I don't know, maybe some of you here have had to deal with programming on these chips, but it's really a mess. You have to program in assembly language usually, and it's fixed point arithmetic, not even floating point. It's really a pain. But those are the kinds of chips that went into early, and even still, some rack mount effects and synthesizers that are in use today. And as things got a little bit more sophisticated, people built some pretty sophisticated computer systems like this ISPW workstation at IRCAM. It was using this custom hardware with DSP chips and stuff. It wasn't using native C++ code or C code running on the general purpose CPU. So it was difficult to program, but it had a pretty accessible user interface still for the users of the software, not the developers of the software though. That was a different story. It was hard. And even today, there are still some dedicated cards you can buy that have all the audio DSP happening on chips, custom chips. But nowadays, people generally, they just use the built-in audio input-output that are in their laptops or desktops, or they'll buy a more expensive box that just shuttles audio into and out of the machine, but does really very little or no actual effect processing or synthesis in the box. It's just a box to get audio into and out of the computer, so the computer can actually do the calculations for effects and synthesis. And then you can run native apps like Ableton Live. It's a lot of fun. Now that we can do that kind of thing. It wasn't always possible. And now the trend continues. We're able to do this kind of thing, or many of these kinds of things that we can do in native applications in the web browser, with many additional possibilities for collaboration. So before the Web Audio API existed, there were some ways to get audio to play in a web browser. And some of those early ways of having audio play were really mainly oriented around streaming audio, and they required plugins like the Macromedia Shockwave Audio plugin and Real Networks, and there was a Beatnik plugin for doing very simple sample bank sequence playback. Apple had the QuickTime plugin. Macromedia, which was bought by Adobe, had the Flash plugin where you could do streaming and actually some custom audio DSP using ActionScript, language kind of vaguely similar to JavaScript. And then a little bit later, 2008, around there, we got actual web standards. Instead of having to use plugins like these previous examples, we started to develop web standards so browsers could support audio streaming and video streaming directly in the browser. That was a pretty big step. So now begins the journey of the Web Audio API. After the audio and video tag came in, there was still kind of a missing piece of how to do more sophisticated audio effects or processing that weren't just simple streaming. So in 2009, I was working at Google, and I started some of the early experiments that led up to the Web Audio API. I was working on a team at Google that was developing a graphics plugin, a 3D graphics plugin called O3D. And it was an NP API plugin, high-level JavaScript API for doing 3D graphics. And it was abandoned after a while once WebGL came on the scene, and Google realized that it was the right thing to do to switch over from a plugin-based thing to something that was web standards-based. There was a big push in Google to stop using plugins and develop and put more resources into web standards. But before that happened, I was working on this O3D team. That's Greg Tavares there. He's a graphics game guru. And for anybody who is interested in WebGL, he has an incredible website for learning WebGL, which I'd recommend you check out. So this was the O3D plugin, and they had a demo page. I was working on the team, not doing audio stuff at the beginning. I was just doing graphic stuff and doing some Macintosh platform-specific code, OpenGL code, and just other miscellaneous stuff to help out the team. Most of the other team members were graphics specialists and much smarter than I was as far as graphics was concerned. So I was just interested in this project and wasn't doing anything audio related at all in the beginning. But after a certain point, I helped out and I'd done most of the important stuff that needed to be done that I could help with. And I realized, or at least personally, I felt that we need to have an audio API to go with this graphics API, because sure, you can have games, but it's not so much fun if you don't have some sound to go with the games. This plugin was really mostly game-oriented, so I started a 20% project, and for those who don't know, at Google, they let the workers there take maybe one day out of the week just to work on their own personal project. And I decided I wanted to figure out how can we add audio to O3D, and what should the API look like. And because it's game-oriented, my thinking at the time was just, well, let's add some game audio API to this to go along with it. So I had worked on an API called OpenAL when I was at Apple. I developed the OpenAL.framework there. And that's a C API, but I thought maybe we could just put a thin JavaScript wrapper around the C API, and then supposedly, you know, there are implementations on all the major platforms, so I thought, well, maybe that would just be an easy way to get audio if we could just make a simple JavaScript wrapper around the C calls under the hood. OpenAL has multiple sources, one listener. The sources are assigned an audio buffer, similar to how we have audio buffer and the Web Audio API. It's spatialized audio. You can pan sources around. It has Doppler shift, distance effects. Sounds get quieter as they get farther away. The cone effects as the sounds are pointing away. It's not as intense. But I discovered very quickly when I started to implement this that OpenAL had quite a few problems as far as making it a standard to where you could write some JavaScript code and get the same result for all the different platforms. For example, especially with reverberation to create room effects and special effects, and also some low-pass filter type stuff, there was really no standardized API. The very base level API was totally standard to just create a source and give it a buffer and play it and pan it somewhere in space. But for reverberation, you had to have a special extension. It was not part of the standard. So for example, Creative Labs had this EFX extension for reverberation, and their reverberation algorithm was custom and it was proprietary code. And then when I worked on OpenAL at Apple, we had a different kind of reverberation algorithm, one I worked on called the MIDI. So we created OpenAL extensions, non-standard, in other words. They're just Apple-specific extensions for accessing the reverb that Apple had. So that wasn't really ideal, that there would be two different, under the hood, just to implement it, there are going to be two different kinds of code paths, and also these reverberation algorithms just don't sound the same. The rooms don't sound the same. Both of the types of reverb are algorithmic, and the source code is proprietary. The algorithms are black magic, so there's just no way to get these different implementations to sound the same. It's not a very good basis for a standard of any kind, and yet that was a state of affairs for OpenAL. So I didn't like that. So how can you solve that? I decided, well, OpenAL is probably not the way to go, but we want something similar to it, like OpenAL, but a new API. I started thinking about what that API would look like to support the same features, but solve this reverberation problem. So I was familiar with an alternative to the algorithmic reverbs. It's a convolution, a technique where you can load an impulse response, just a standard audio file that represents the impulse response of a room. It can be very rich sounding, a huge cathedral or just a medium-sized room or anything. And you can also create impulse responses for many kinds of interesting special effects with weird filters and delays and stuff like that. So I thought that would be a good way to solve the problem of standardization. How can we standardize reverberation across all the platforms? how easy would it be to implement cross-platform code to do the convolution effect? So I actually was familiar with some techniques for high-performance implementations for convolution, so I started writing the code. It's multi-threaded. It's very fast code. It's calling into FFTs, which are highly optimized. So I spent a good number of weeks, maybe even months, working on this code, but I was convinced that it would be the right solution to solve this problem. And I even had some fun. I went to a friend's warehouse space and recorded some impulse responses. It was actually a great sounding space. And I didn't have to do this for the project, but I just was interested in doing it since I was implementing the algorithm anyway. So this was early 2009. I was working on this as a 20% project, and all of my implementation was just done on my local machine. There was no proper source control because I was actually, at this point, the O3D project had been canceled, and they were transitioning over to, the graphics engineers were starting to work on WebGL, but I was still working on this audio code as my 20% well, I was kind of transitioning into my 100% project at this time, because I wasn't working on WebGL actually very much. I had to learn how to put code into a web browser, and the Chrome browser was using at that time the WebKit open source project, which is also used by Apple for their Safari browser. I had to learn how to get around and navigate the code in WebKit, which is very complex. And to make things worse, Apple has a separate JavaScript engine, a JSC engine, and Apple has a V8 engine. So the JavaScript bindings are completely different for Chrome and for Safari, but everything else in the underlying web engine is the same code. So I had some bindings that could be automatically generated by IDL files and other bindings that were more complex, and I had to write custom binding code. I had to write it separately for the Apple JavaScript and separately for the Google V8 engine. It was a real pain because they didn't let me check in any of my code into the WebKit open source project, because WebKit, they said, is not for doing experiments. It's for doing serious web development that is backed by web standards. And at this point, this was just an experiment. I started this as a 20% project. Nobody knew anything about it. Nobody in WebKit knew anything about it at this time. So I had to basically just check out the WebKit source code and hack into it, adding the bindings for V8 and for Apple's JavaScript. And every time I updated the source code, I had to handle tons of terribly difficult merges because I didn't have my own branch to work on, official branch. That lasted for a couple months, and it was really difficult. So the early API that I had at that time was much simpler than what we have now in the Web Audio API, but it had some important features that are still in the spec today. High resolution, scheduled playback, the audio buffer source node, IDEA for doing one-shot sounds, loops, and grains, the convolution reverb that I mentioned, spatialized panning, similar to OpenAL. It had visualizers like we have the analyzer node today, and I spec'd out a low pass and a high pass filter and dynamics compression. So those were all in the very early API. But there were some differences. Back in the very early API that I was working on, it wasn't modular. It wasn't based on nodes that you could connect together in arbitrary graphs. It was monolithic. All of the sources had a fixed pipeline where you could change the pitch, the playback rate, really. And it had a built-in occlusion filter and obstruction filter. And it had a built-in panner. Every source had all of those things built in, and it had two outputs. I guess it had a send output and it had a main bus output that then went into a fixed mixing architecture. you couldn't create gain nodes and create your own types of mixers. It was just a fixed mixing architecture, pretty much doing the same type of thing that OpenAL was doing under the hood for just playing one-shot sounds. So I presented a design doc at Google, and I presented also at Apple. I managed to snag a meeting with some guys on the WebKit team at Apple, and I'd like to show you what that design doc was. So let me get out of the slides and I didn't want, sorry, bear with me please. I'm going to resize the window. Okay. So this was the design doc. It's kind of a precursor to the very first version of the web audio spec. I didn't even have a name for it. I called it Web Audio System, not even Web Audio API. And you can see motivation. Audio on the web has been fairly primitive up to this point and has had to be delivered through plugins. There may even be some of this text still in the spec today. I'm not sure. It's possible. So I had some demos that I presented at Apple in the first meeting. One of them was Box 2D, some of you may know, and I added some hacks in there to spatialize the sound of all of the collisions and create a nice rich sound when you're dropping all these shapes. I created a simple drum machine and a very simple music visualizer that I showed them. And let's see, just scrolling down. It's a very simplistic design document compared with what we have now in the spec. I'm describing some things that basically just OpenAL type of features. And I even have some IDL in here. In those early days in the spec, it wasn't even an audio context. I didn't know very much about JavaScript or web development. I kind of just came into Google not knowing any of this stuff, and I just learned as I went along. But I thought, well, we'll create the API based on a new tag. We'll call it the X audio tag. But you can see that the interface, it has a listener, like we have in audio context. It had an impulse response buffer because it was a fixed convolver that was basically in this audio context. Had a real-time analyzer that was just built into the audio context instead of it being modular. But it has the current time attribute. That's still there. And I had a special API called create audio request for fetching an audio resource like a WAV file or MP3, and you would give it the URL, and then it would call you back. And then to play a voice, you would get voice. There's an audio listener, which actually is somewhat similar to what we have now in the audio listener. It's an audio buffer, which actually we still have today. Audio buffer. The API is not exactly the same, and it's a little bit different, the names, but don't have get. You can't get the channel data. Well, those early days. So, and then there's an audio source, which would be the audio buffer source node now. So it has a buffer attribute. That's same, but it has all of this extra stuff. It's monolithic. It has all this stuff related to panning built in, the reverb blend, which is like the send amount to the reverb and so on. But it has play grains, and that's now called start, and there's start. Let's see. Audio effect parameter. That's called audio param now. But some of the properties are the same. Name, min value, max value. Real-time analyzer. A lot of this API is actually the same as what we have today in the analyzer node. So anyway, that's a very early design document. So that was presented to Apple in late 2009. And there were a couple additional meetings in early 2010, like January and March 2010 I had with Apple. So they had some comments about this design doc that I showed them, and especially the API. So I called 2010 the modularity year because it's where the Web Audio API became modular. And incubation because that's when the W3C created the Audio Incubator Group, which we'll see. So some of the early feedback from Apple about my design document and some of the demos that I played them was that they didn't want me to create an X audio tag. They thought that was silly. Why not just have a constructor and create a new object? And so I had to think of a name for this object. I didn't have a name for it, so I thought audio context makes sense. So new audio context. Now we have a context. We can do things with that. And Apple didn't like the monolithic approach that I had, where you couldn't create boxes and connect them together, or nodes and connect them together in arbitrary configurations. They were familiar with audio units that I had worked on at Apple, and they wanted things to be modular. So I was kind of excited about that idea because I knew it would be powerful, but I was also a little bit apprehensive because I had been working really hard on this stuff, and I just wanted to move forward with it. But I realized that it could be possible to change the code a little bit and work on it pretty hard and think a little bit about how it could be modular. I was familiar with modular approaches to audio in applications like Reaktor and also Max and other stuff that I even had worked on myself in the past. For example, at Apple, I worked on the core audio team, and we had a simple API for connecting audio units together called the AUGraph API. And a special note here, we have two APIs, they're C APIs, AUGraph connect node input, AUGraph disconnect node input. And it's not an object-oriented API, really. I mean, C is not object-oriented, so you have to pass things in as arguments that otherwise an object-oriented you would just call as a method. So if you look at the connect node input and disconnect node input, it actually looks an awful lot like what I came up with for audio nodes. I had to come up with a name, first of all, for what would these boxes be in the API. So I decided to call them audio nodes. And the first methods that I created for these audio nodes were connect and disconnect, and I modeled them basically after what I had done at Apple, more or less. Very similar approach. And so I got to work on designing that API and changing the code so that I would split the different functionality out into separate nodes. And I created this diagram, I think around March 2010, and you'll notice that there are mixer nodes. There's a dry mixer there and a wet mixer. So actually similar to Reaktor, Reaktor also has mixer boxes, or whatever they're called in Reaktor. And so I was just, my initial idea was, well, in order to do mixing, we'll have a mixer node. Why not? So that's what it looked like in March. And another thing I had to really think about is how are you going to handle dynamic sounds being played, like one-shot sounds, play sound now, have many different simultaneous sounds playing that are stopping and starting at different times, like for drum machine or just for games or other types of applications. So these are short-lived parts of the graph. So all of this part of the graph that's within the dotted line only lasts, it starts at a specific time and it ends at a specific time. And I was thinking, how do you handle the object lifetime for these things? It would be awfully painful for a JavaScript developer to have to connect these nodes up and then do like a set timeout or get some callback when it's finished and then have to manually disconnect the nodes one by one. I thought that would be terrible, so I thought, is there a way we can just have the underlying implementation just disconnect these things automatically when it's the right time? So this one-shot sound, it has a specific start time and a specific end time. Or maybe it's looping. Maybe it doesn't have an end time. Maybe it's looping and it lasts forever. That's a possibility too. But if it is playing for a limited amount of time, it's going to have a stop time. And so under the hood, I found a way where the implementation could just understand that it's finished playing, it's connected to this thing, and that node can go away, and then the panner node can go away, then the gain node can go away, and it gets all torn down automatically. And then as far as on the JavaScript side, it just gets garbage collected. So I thought that was pretty neat to be able to have just a fire and forget type of approach where you connect these nodes together, you play, and then it all works. Don't have to clean up after it. So let's see. Around May, I guess, of 2010, Doug Scheppers created the Audio Incubator Group. Now this was a W3C group that was a precursor to the audio working group that we have today. So if anybody is interested in the history of the early discussions, it's not on the main audio working group mailing list. It's on the incubator group mailing list, which is a public XG audio at w3.org. So many of the very early conversations are on that mailing list, and they're archived there if you're interested. Doug Scheppers contacted me. I think that Eric Carlson from Apple was contacted by Doug, and then Eric Carlson told Doug about me doing this work at Google, and so Doug Scheppers from the W3C contacted me, inviting me to join the group. And at this time, Mozilla was working on something called the Audio Data API. So we had 3 different companies joining, and I think the BBC joined. Chris Lois probably was there in the very earliest days, yeah. And maybe a few others in the group here. So this was a turning point where it was starting, people were starting to take audio in the web browser seriously. And it was not an official group, it was just an incubator group, but at least it was being taken seriously by the W3C. So I sent out my first email to the group, I guess this is dated June 14, 2010. This is what I said. The group is just starting to get rolling. I'd like to introduce myself. And at this point, Apple actually gave me a special branch, Subversion branch in WebKit. I wasn't able to check in any code in WebKit trunk. I had to work on a special branch, but it was actually much better than having to do all the merges on my local machine without even having my own branch, I can tell you. So I gave them a link to the code here, first of all, and then I gave them a link to the very first version of the specification and a link to a demo page. And I said, I'm interested in getting feedback on the specification. So this is the first version of the Web Audio API specification. I actually have a version of it I can show you if I get out of here. So I think it's dated. I sent it in the email in June, but I actually made this document in May, 24th May 2010. The specification provides an API for processing and synthesizing audio and web applications. The primary paradigm is of an audio routing graph or a number of audio node objects. I think some of this text may still be in the current spec. And then I talk about audio nodes and audio context, audio param, audio buffer. So those lasted. But some things that didn't make it, audio mixer node input. I have audio source node, it's called audio buffer source node. Panner node, some of these things, there's no impulse response interface. But the convolver node and analyzer node, yeah, it's kind of similar to today. I talk about all these different kind of filter effects. Didn't have a way to automate the audio params, but I did kind of think maybe we should have an audio curve interface. It's not the way the API ended up, but I thought WaveShaper might be good. Dynamics processor. I talk about chorus in here. It never ended up making a chorus node, although you can make a chorus effect today by modulating a delay with an LFO. So just scroll down a little bit. This is a very early version. It's much shorter than the current spec, but it's much longer than my very early design document. So audio on the web has been fairly primitive up to this point, until very recently has had to be delivered through plugins. That's still in the spec, I think. I talk about modular routing. And in this first version of the spec, I have this mixer, idea of the mixers that I mentioned. Dynamic lifetime, like I mentioned. Let me put the mic down for a second. Yeah, I talk about panning, how spatialized panning can work, how convolution can work. And I even show some of the demos that I created, although those aren't really appropriate to be in a specification, so that's been removed. But this was just trying to introduce people to the idea. This was the very first version of the spec. Yeah, security considerations. Well, there should be some, but I didn't know what to say at the time. Okay, so yeah, I mentioned that Mozilla was working on a different alternative API called the Audio Data API. David Humphrey had been working on this, I think, in late 2009. And so there were many discussions on the mailing list about the two APIs. And I realized that we would need to have a way to process DSP code directly in JavaScript. And in my very first version of the spec, I'm not sure, I may have mentioned a JavaScript audio node, or maybe in a few weeks or months after that, I added it to the spec because I knew we had to have a way to process directly in JavaScript. So some early feedback. Apple had a guy named Jared Noble who had been at the early meetings that I had with Apple, and he had seen the early design docs, and he saw the work that I did to make it modular and everything. And he didn't like the idea of having a mixer node and a mixer node input. And he said, well, why can't you just have the mixing happen automatically? If you have a node that has connections from multiple other nodes, why can't the mixing just happen automatically? And I thought, yeah, that would be great, actually. Why force people to create an explicit mixer node? It's just extra work, and it's unnecessary. So I also had this idea of an owner concept. I'll show in another slide what I did, and it was just a little bit awkward, and he said, just get rid of that. We don't need that. So back to this mixer thing. This is what the first diagram looked like, with the dry mixer and wet mixer. And then there were additional nodes, audio mixer inputs. That's what in1, in2, and in3 are. You had to create a mixer input for every mixer, and that's what you would connect to. It was kind of cumbersome. So this is how it turned out to be when the mixing happens automatically. We had to create a gain node. That's what the dry 1, dry 2, wet 1, wet 2, wet 3 are. So if you want to change the level of a particular source into the mixer, you just create a gain node, and then you connect that into another node, and the mixing happens automatically. You don't need a mixer node at all. And in the early specification, I had this idea of an owner that you would pass in. So you see where I'm passing one-shot sound as the owner. That was to handle dynamic lifetime. And then off on the right, that's what's in the current spec. You don't pass an owner in. The implementation under the hood is able to figure out well enough, based on the connections and based on the lifetime of the nodes, what the owners are, or what the implications are for the connections, and how to tear down parts of the graph that are no longer needed. So that's something very quickly I fixed in the spec and I fixed in the implementation. So in that first email I sent out to the mailing list, I had a demo page. Unfortunately, this isn't a snapshot of the very first demo page that I put out. It was maybe this is like a year or two later. I don't have access to the very first demo page, but I sent out demos that actually were working. And later on, probably over the next 6 months to the next year or two, I started adding a second part of the demo page, which were stuff that external developers, outside developers were doing to kind of showcase their work. And people were doing some really cool stuff pretty early on, just like within 6 months of me releasing some early builds. So talking about builds, I was working on the code for web audio in a special branch of WebKit, which is still there. Actually, if you want to look at the early code that I stopped working on within a few months of posting it to the mailing list, but it's in svn.webkit.org. You can go to the branches and find it in the old branches. So this particular page just said that you can just use stable builds of Chrome, or you can use Canary builds, and then I talk about nightly builds in Safari. But this is a later page. Earlier on, there were no builds available in Chrome. It wasn't shipping in Chrome. It wasn't shipping in Safari. I just was working in a private branch in WebKit, so I had to create builds myself, or give build instructions to people if they wanted to try it. So I just had binaries that I posted to this demo page. People had to download the binary to actually run Safari. I actually, believe it or not, the first binary I posted was to Safari instead of Chrome, because it was easier to build, actually. So one kind of sticking point that people had with the API was how to fetch audio resources across the network. I had this create audio request API where you give it a URL and it would go and fetch the WAV file or MP3 or whatever and do the decoding. But people didn't like that I had a separate network API. They wanted me to use XML HTTP request. But the problem is that in 2010, there was no way to get binary data using XML HTTP requests. It was a text-only API, so you could fetch any kind of text, but not binary data. If you wanted to fetch binary data, like what WAV files are, or MP3s, you had to encode it in a text format, like base64 or something like that. And that kind of defeats the purpose of having compressed audio. If you're just gonna do base64 encoding, it's kind of ridiculous that there's such a limitation like that. So I had to go to the working group that was responsible for XML HTTP request and talk to people on the list about how can we add binary support. So we worked out two new properties, request type and request. And you would set the request type to array buffer, and then now you can fetch binary data. And I actually implemented that in WebKit myself in November 2010. And it's, as a byproduct of that, everybody benefits from getting binary data now, including WebGL and other things. It would be terrible if we had to do base64 encoding for large WebGL assets or audio assets, you know? So that brings us to 2011. We started to get some browser releases in 2011. So in March of 2011, we released Chrome 10 with Web Audio API included behind a flag. It wasn't enabled by default, but if you were just using Chrome 10, you could go to About Flags and you could enable Web Audio. And then shortly thereafter, We got Windows and Linux behind a flag. And then we got it enabled by default in September. And Safari started having nightly builds in October. And then you can see later on in later years, other browser vendors started jumping in. Firefox comes in and Microsoft in 2015. So that's great. But we're still in 2011. We're talking about what happened in 2011. So there were many mailing list discussions and some controversial discussions about what audio API are we going to use? Are we going to pick Web Audio API as a standard audio data API from Mozilla, or a new API that Robert O Callahan had just devised called the Media Stream API? And then mixed in with some of these discussions, just to add some spice, Ian Hickson, kind of HTML guru who worked at Google, he works on a lot of the web specs, the specifications for HTML5. He said we shouldn't even be working on audio APIs. He actually sent an email to the mailing list and said we shouldn't be working on APIs at all. We're too busy working on other things. So nobody on the list was very happy to hear from him about that. So we just ignored it. But it was kind of a funny thing for him to say. So in May of 2011, I kind of saw that we had separate nodes for the filters. There were all these different nodes for low pass filter 1, low pass filter 2, low shell filter, high shell filter. And it was just too many nodes all doing filters. So I thought, let's just simplify it and make one filter node, the biquad filter node, that can be configured to any of those filter types. So that was a simplification without losing any power. And that's just showing the biquad formula. Because under the hood, all of those filter types are implemented using the same equation. The coefficients are just changed. In June of 2011, we got the ability to automate audio params, which is really powerful. You got set value at time, linear ramp to value at time, set target at time, and so on. In July of 2011, we had some discussions on the list about the WaveShaper node. How should that work? And so it doesn't have a very complicated API. You basically just give it a curve and you have an optional property to do oversampling or not. So I implemented that and added that to the spec around July. And in 2011, I guess in April or around there, Robert O Callahan proposed the Media Stream API on the mailing list. And this was, Robert O Callahan wasn't interested in the Web Audio API. He said also, though, he didn't want to he didn't want to choose the audio data API either. He created a third API. And his motivation for doing that was that there was some big interest in WebRTC at the time for doing video conferencing type of applications and talking to remote peers and getting access to the live microphone. That's important. So he had about 14 use cases in his document. He had his API, but he also had 14 use cases, which would be important use cases for integrating audio into the WebRTC API, which uses these things called media streams. And they were excellent use cases, but I didn't like the idea of just abandoning the whole Web Audio API just because we have to do these use cases. It's true we couldn't do that in the Web Audio API, but I thought we could create a couple new nodes to handle those things. And so I adapted, he actually had pseudocode using his API for doing these things, and I adapted his examples to use the Web Audio API using these new nodes. So there were a lot of discussions about that kind of thing. And I think in the fall of 2011, there was a TPAC meeting was it in San Francisco or it was in San Jose. TPAC is, I think, an annual meeting of W3C where a lot of web standards are discussed. And I think that's where I met Chris Wilson, actually, was at that TPAC meeting. And I was there, of course, for the web audio working group, but I also went to the WebRTC working group meeting and presented my ideas for integrating the web audio API into WebRTC. So that was near the end of 2011. I presented those ideas, but I didn't have any implementation, and I hadn't completely spec'd it out. But by, I guess, January of 2012, this is slightly different. It's not WebRTC. This is integration with the media element. So audio and video tags. You have to have a way to be able to get audio from an audio tag or a video tag and pipe it in as a node into the web audio API. So that's where we get the media element audio source node. And just kind of jumping around here, in March of 2012, we had discussions in the working group about oscillators. I felt pretty strongly that oscillator was kind of essential building block to have in an audio system. So I spec'd out the OscillatorNode and wrote the implementation in WebKit for that. And I tried to do it the best I could to make it really high quality and anti-aliased. In April of 2012, we got a new powerful feature, and I didn't create this diagram here. Somebody was kind enough to add this into the latest spec, but it illustrates the technique or the feature that we added in about April of 2012, the ability to connect an audio signal to an audio param. So in this example, we have an oscillator that's running at 440 hertz, and it's being detuned by a second oscillator that's running at 1 hertz, and it's sweeping from minus 50 cents to plus 50 cents at 1 hertz. So it's an LFO modulating the pitch. It's powerful to be able to not only use the automation APIs of audio param, but also to be able to connect audio rate signals. So I was working on all these different things at the same time, and I had to finally get around to working with the WebRTC team at Google and implement the Media Stream Audio Source node and Media Stream Audio Destination node. So I think we got those implemented in spring, and it was a lot of work to coordinate with the team. There was a large team at Google working on this video conferencing type of engine that was underpinnings for the WebRTC API, which was really in flux at the time, lots of changes, and it was very complex in the code too. So as a consequence of doing all that WebRTC integration, we got live audio input in September 2012. So now you can plug your guitar in and have distortion effects and reverb and delays and choruses and filter effects and other kinds of live audio input processing with your voice. So an important thing in 2012 is Mozilla agrees to implement the web audio API after many discussions, and so that was a really big deal. In the summer of 2012, the work starts. I believe that's around the time. And now that Mozilla is working on the implementation, they're going through the specification with a fine-tooth comb, and they noticed some discrepancies in the naming. So we changed the names of some of these nodes to get a more uniform naming. And there were several other similar types of cleanup things that were done at that time. And then a little bit later, I guess around January 2013, Robert O Callahan was working on the implementation in Mozilla, and he noticed that the specification was not really clear about how does the mixing happen when you connect multiple audio nodes to a single audio node input. So I had to think about it for a few weeks, and I worked out 3 new properties on an audio node: the channel count mode, and channel interpretation. And I had to write some text in the specification to explain in great detail exactly how you can set these properties and get many different kinds of mixing. And generally, if you just want to do the normal things, the these properties would be automatically set to do the normal types of behavior, but you can set them to do other interesting things. For example, if you are rendering to a multi-channel speaker system of 18 speakers or something like that, you might have to set these to different values. So in 2013, I had been working on all of this stuff, but it was fairly mature by this point with the integration with WebRTC. I had some time to think about the Web MIDI API. That's API that Chris Wilson and UC Kaliokowski, I'm not sure if I'm pronouncing his name right, those two started the specification in March of 2012. And a year later, like I said, I started to have some time to think about implementing that. And Takashi Toyoshima at Google Tokyo office and we started working on it. But Takashi, he proposes that we implement the Web MIDI API to the WebKit dev mailing list. And remember, WebKit is used by Apple as well as Google and others. And Apple reacted strongly against implementing the Web MIDI API. They said, well, we don't want to turn the web browser into an operating system, and that's just going too far to have MIDI in the browser. And I strongly disagreed with that, and I think Chris Wilson did as well. And we were very determined. And Takashi in the Tokyo office, he was very determined. We three at Google were very determined to get Web MIDI implemented somehow or another. And strangely enough, this is just around the time that Google forked the WebKit project into its own open source project called Blink. And some of these issues with Apple were less important. We still, I really do hope that Apple one day will agree to the Web MIDI API. I don't want to downplay that, but we at least had a chance to implement the Web MIDI API as an experimental feature behind a flag. And even internally at Google, there was some discussion and some pushback on whether we should do this or not. And Chris Wilson and I and Takashi had to work out a very detailed design document and kind of sell it around inside of Google to get agreement within the team for us to do this. But by spring of 2013, we got approval, and Takashi and I implement the Web MIDI API. We each did about half the work. I did some of the Mac-specific code and some of the browser IPC for the cross-process communication, and Takashi did some of the other underpinnings. And we got it working pretty well initially, and we shipped it behind a flag, Mac only, in spring 2013. And then Takashi continued to work on it for the other platforms, and I think he got them all, including Android, by spring of 2015. So I left Google shortly after that time. I left Google in the summer of 2013 to retire. I was satisfied with what I had done, and I was a little bit tired maybe after doing all this work. So I retired and I went home to do my own work. But the work continued on the Web Audio API over all these years, and one of the most important new developments is the audio worklet. So I just wanted to quickly touch on this. So it was released recently, I guess early this year, by Google, an implementation of audio worklet. And just briefly going back to look at processing directly in JavaScript, there was actually Flash ActionScript processing several years even before 2010. ActionScript is similar to JavaScript, so it's the same idea. Audio Data API by David Humphrey, DSP code in the main thread, and my version of that, script processor node, runs in the main thread. And MediaStream API even had a version, but it was running in a web worker thread, which was better because it was more resilient, couldn't get messed up by main thread, other things. And audio worklet is supposed to run in the audio thread. Although I've just recently heard it's also not running in the audio thread, it's running in another thread. But it's still much more resilient to glitching. So yeah, this is just showing the different threading and glitching types of ramifications of these different APIs. And I'm really happy to see some people here at the conference doing some work with Audio Worklet. I had nothing to do with it, by the way. I'm just excited that it's a new development. So that's it for now. Thank you very much.